Welcome everyone to AVATA's first AVATA Academy workshop. This series of workshops is a little different from our typical webinars. They're designed to be a little bit more technical with live demonstrations, and we'll leave some time for Q&A at the end. Our topic for today's workshop is how to create and use causal factors in Demantra. Presenting for you today are Ken Spigarelli, Managing Partner at AVATA, and Andrew Calder, Director of Consulting, AVATA Australia. Just a few housekeeping notes. All attendees will be muted throughout the presentation, which is being recorded and will be made available to you. Questions can be submitted through the webinar side panel. We will reserve time at the end of the webinar for Q&A, but we may also take time to answer some questions as we go along. And now I'm going to turn it over to Ken, who will give us a brief introduction to AVATA. Ken?
Yeah, thanks, Deb. Hello, everybody. Welcome and thank you for joining today's AVATA Academy session. As Deb mentioned, my name is Ken Spigarelli. I oversee the global operations for AVATA. Before we get started with today's session, let me just briefly introduce our organization. We're a certified Oracle partner specializing in helping organizations get the most value out of their Oracle on-prem value chain planning solutions, as well as their cloud ERP and cloud supply chain planning investments. Our team applies best practice business process principles together with senior systems expertise to ensure you're leveraging your tools in the most effective and efficient manner. In today's session, we turn our attention to demand planning, specifically forecast accuracy and ways to increase accuracy through the use of causal factors within Demantra. I'm pleased to introduce one of our senior Demantra solution experts, Andrew Calder. Prior to joining AVATA a few years ago, Andrew spent 20 years with Oracle. Most of this time spent specifically assisting and educating companies such as yourselves as how to best configure and tune the Demantra engine. He's organized a really great session for you today, and I hope you are able to take a few learnings with you from today's meeting. Andrew?
Okay, thank you, Ken. Hopefully you can see the agenda that should be up in front of you. And what I'm going to do is I'm going to just introduce and describe what causal factors are and how to basically use them. And then we're going to dig down into one particular type of causal factor, and that's local causal. I'm going to show you how to use that, and I'm going to show you how easy it is to use it and how effective it is to use it as well. So we'll run through the basic instructions of how to set it up, and then I'll do a live demo as well, so you can see it actually happening before your eyes, and then we'll run through some Q&A, as Ken said before. All right, so that will be our agenda, and I'm going to start with some introduction to the topic. So first up, let's just talk about the fact that the engine for Demantra, of course, comes in a number of different areas. It's actually a very comprehensive system, and it includes lots of different engine parameters, a forecast tree which defines the way the data is aggregated from the bottom to the top as the engine scans through the data and tries to forecast it. There's a whole bunch of different statistical models, regression models, halt, intermittent models as well. And in addition to that, there's of course the Bayesian blending of those models together. There's a promotional engine. There's multiple engine profiles. And most important, I think, of everything that what Demantra actually provides to the planner is causal factors. So anytime we talk about regression models, we're talking about the ability to provide causal factors as a way of modeling historical data and using that to drive a better forecast going forward. So that's what I hope to demonstrate to you today. So let's just talk quickly about the purpose of a causal factor. So basically it is to model the effect of changes in the marketing mix and external factors on future demand and thus potentially significantly improve forecast accuracy. So take a look at this sample of 13 weeks of data which I provided here, which obviously is not real data, but it's just giving you an example of how it would work in practice. So let's say that our normal weekly sales rate is between about 80 to 100 units per week, but we can see in the history that we have a big spike in demand which pretty much doubled the sales in 1 week. There was a dip in sales in another week, and there were 3 kind of medium-sized increases in sales in these 3 weeks here. And what we have identified is that the first week was a price promotion, the 7th week was a competitive promotion, so it cannibalized our sales, and those 3 weeks, 10, 11, and 12, were all on advertising. So what we can do is, knowing that information, we can model those as causal factors to explain those variations in sales over time, and then use them to drive a better forecast going forward. Now, what I haven't shown there in those 13 weeks, for example, is other really common causal factors that we use almost all the time, such as trend and seasonality. So that would also be overlaid typically on data like that as well. Okay, so that's the purpose of a causal factor. There's 4 different types of causal factors. Let's go from the simplest to the most complex. So the simplest kind of causal factor is used all the time, global causals. And they're simple because they vary by time only, meaning that in the back end of Demantra, there's a table called inputs, and it holds a whole bunch of standard causals, such as seasonal causals, which are called D1 to D12, which you might have heard of before, trend, and other things like global holidays like Christmas, Thanksgiving, and so there's some of the ones that are out of the box, and you can also create your own, such as like an end of quarter effect type of thing. And as I said before, they vary by time, which means that those causals are applied to every single combination in the database. And coefficients of when the engine runs may differ for each of the different combinations, but those causals will apply to all those combinations and will be evaluated for all combinations. Whether a particular combination ends up using those causals or not is another matter, or how strong the causal is another matter, but they will be used because they vary by time only and not by individual permutations of product and location. That's where a local causal is different. It varies by time, product, and location. So typically you'd use local causals to mark things in the data which is specific to certain combinations, such as events that have happened historically, or out of stocks, or maybe you want to model average price data over time for certain combinations. And obviously each different combination would have its own pricing data, so therefore it would need to be stored in a local causal. Or things like advertising expenditure. You can just let your imagination run wild. There's all kinds of things that you may want to try to model using a local causal. So what we're going to do today, in a moment, I'm going to show you how you might mark events. So that's the example I'm going to use. So local causals is what we're going to focus in on. And both of global and local causals are available in the demand management basic Demantra software. So you don't need to have AFDM, Advanced Forecasting and Demand Modeling. You don't need to have PTP or any other module like SNOP. You just need to have DM. Now, promotion causals, which vary by time, product, location, and a promotion dimension, which means that individual promotions can be marked as a particular entity, and then that particular entity, you store the details of the promotion against the entity, and that would be things like normal price, promotion price, display type, and any kind of sophisticated variation of those things. So they get stored against an individual promotion dimension. And the other thing that's different about promotion causals is that they create uplifts which are differentiated from the baseline forecast. So it does uplift modeling. And that's something even more sophisticated again than a local causal. And then finally, we have activity-shaped causals, which are rarely used, but actually very functional. And maybe one day we should do another session on activity-shaped causals because it actually is a really useful way that Oracle has provided to define and model new product introductions, or indeed the whole life cycle of a particular product in a particular market. So they're the 4 types of causals, and as I said, we're going to focus on creating a local causal. So now, the second part of the agenda is to run through some basic instructions of how to create a local causal. So let's do that now. So the first thing I'll do is I'll just give you a scenario of what I'm trying to achieve. I've created some history for this particular combination. So it's just an item within an organization, and I've set every single week to 100 units per week, except for a few sales. As you can see, they've spiked up to 200 units per week. But the forecast that's being generated is using HALT, and you can see that the forecast going forward into the future horizon, the green line going forward past the blue line, which is all the historical sales, is set to around about 120 units per week. But let's just say, what if that would be fine if all those historical spikes there were actually random fluctuations in the data we could not model. But let's just say that they were identifiable historical events. And what if we could also predict when future events were going to be happening in the future as well? In that case, then the forecast that we're seeing here does not adequately reflect that history, and is not a particularly good forecast. It's not particularly helpful. So what I want to do is I want to create a forecast that is pretty much 100 units per week going forward every single week in the future, because clearly there's no trend and there's no seasonality. So it's just going to be a flat line, except for when I have identified events in the future horizon as well, in which case I want the same kind of spike that I'm seeing historically to happen in the future. So that's my scenario. Okay, I'm going to just run you through the steps. Pretty much there are 6 steps that we need to go through. And I'm going to run you through just at a top level first, then I'm going to show you some screenshots, and then I'm going to actually show you live in the system as well. So the first thing is we're going to create an editable sales data series, and that's going to be the series that will actually store the causal factor. And we'll have that causal factor available to us on a worksheet in Demantra, and we'll edit that causal factor to align it up to the historical spikes that we're seeing. So that's the first thing. The second thing is we're going to configure the causal factor, and we're going to reuse an existing causal factor called placeholder 1 in this particular example. So I'll take you through into the causal configuration screen, which perhaps some people have never even seen before, who knows. And I'm going to take you through some extra recommended steps, which are not 100% necessary, but will be helpful. And that is, we're going to set the engine models to regression only. That is, when I say regression, I mean it's the linear regression, because there's a whole stack of different Demantra engine models, linear regression and logarithmic regression and Monte Carlo and modified ridge regression, all these type of things. But the easiest regression model to really understand and use for this kind of testing is just a straight linear regression. So that's what we'll do. We'll try to simplify things as much as possible. We'll also ensure that our stat forecast and simulation series show the backcast and not just the forecast. That helps us to see that our modeling is working properly. We'll ensure that the parameter forecast generation horizon is greater than and equal to the history length. That means that the backcast actually gets generated by the engine so that we can see that alignment. We'll then go in and add the series to a worksheet alongside, when I say the series, I mean our editable sales data series, which contains our causal factor information. And we'll add that side by side with the history, the stat forecast, and the simulation series as well. And then we'll go ahead and we'll enter some causal data into the series. And what we need to do, we need to do it at least for the historical horizon in order to do the historical modeling, preferably also for the future horizon as well, so that we get those future spikes being generated. And then we'll run the simulation, and then we'll repeat these steps as necessary. Okay, I'm going to flick to the next screen, and I'm going to show you each of these steps, screenshots from these steps one by one, just to give, again, a quick overview, and then we'll go into the live demo. All right, so this is what we're going to see. We're going to see a series that gets created. We're going to call it Demo Local Causal with this internal name. It's going to be a series that's on the sales data table, and it'll be, because it's editable, you'll have this update field, which is the same name as the internal name. And then we'll have a server expression that just picks up the value of that particular series in a very simple way, just picks up the average of that series. So that's the first one. First step, create the series. Okay, so the next screen is to configure the causal factor. So it will look like this. Basically, have all the other causal factors, D1 to D12, winter, summer, Christmas. They're all turned off at the moment. But we're going to use this one called placeholder and tick placeholder, and we're going to use that as our causal factor. And the way we link it to the series that we created is by entering data into this local function here on the causal factor definition screen. So it's that very similar expression to what we had before in the actual definition of the series itself. So it's using XXDemo local causal. All right, so the next one is these extra recommended steps I mentioned before. So we've set the engine models to regression. That's ticking this box right here. You'll notice I also have crosstons for intermittent also turned on, but actually that's irrelevant because the particular combination that we're using has got dense data. It's not intermittent, so therefore that model, even though it's turned on, will never get used as long as we're looking at dense data. So that will be fine. The client expression, in order to ensure the stat forecast and simulation series shows the backcast and not just the forecast, the simple way to do that is just turn off the client expression, just make it blank. Don't have any client expression there. And then finally, in terms of the forecast generation horizon parameter, it's this particular parameter here, and I'll show that live in the system in a moment anyway. So what we'll do is we'll add the series to a worksheet that I've already created before, as I said before, alongside history and stat forecast and simulation series. So there's my history is the override there, and then the adjusted history. My baseline forecast is the stat forecast, and then my simulation is this one here. And I'm going to be focusing on the simulation. And then also we have engine models and forecast tree level, which just tell us something about the forecast that's being generated, which particular engine model it has used and what level of the forecast tree it was created at. Now, just as a postscript here, to see the series that we created before, we would normally have to restart the web server, but I've pre-created this series, so we don't have to go through that step during this demo. Okay, inside the worksheet, we'll then go to this particular, we'll add the series we've created, Demo Local Causal, into the worksheet. We'll enter some data into it, and we'll run simulation. So that is the basic steps via screenshots. Okay, let me take you into a live demo now. All right, so to create the editable sales data series, literally we're just going to go to configuration, configure series. Normally we would right click in here and say, new series, or maybe create as if we have an existing series we want to copy. But since I've created it before, I'm just going to go straight to it. Demo causal, local causal. So there's the definition you saw the screenshot of before. It's editable. It's got a hint message. We'll just go quickly through some of the properties. Display type of table and graph, so I can see it on a graph as well with its purple color. Let's move on through to data properties. So I mentioned before, it's on the sales data table. And just remember, it's on sales data because of the fact that this local causal, by definition, is variable by time and product and location, and they are the dimensions of the sales data table. So that's why it needs to be on sales data. And then finally, the expression, the server expression we're going to use, and no client expression. And that is pretty much it, apart from just setting the security to whichever users you want to be able to see it. Okay, next thing is to configure the causal factor. And to do that, we go into the forecast tree, pick up our engine profile, which is batch. Just move through the tree and through the wizard, I should say, until we get to this screen, the causal factor screen. And what we will do is we're going to go and reuse this out-of-the-box causal factor called placeholder. Make sure that it's set to local. We're going to tick it on for the short models. And the reason why we're going to use short is because, remember before I said we're going to use just regression, linear regression for a moment. Well, linear regression is by definition a short model. So therefore it needs to be ticked on for that one so that it gets picked up by linear regression. There are different types of engine models in Demantra. So other engine models, for example, like Monte Carlo is a long model, and B-Wint is a short model, you know, so there's different types of engine models and they align to a different kind of grouping that's in this screen here. But anyway, let's stick to the simple stuff here. We're going to use placeholder. We can just leave it at that name placeholder if we want to, but we could also rename it to something that makes sense, so that when later on we come back and look at this, we know what it is. So let's just do that. We'll call it demo local causal factor. And when we slide across here, this is where we go and set up the local function. So as you can see, I've already typed it in there. So that again looks directly at the series, the name of the series, or at least the name of the column that's in the sales data table. Very similar to the server expression of the series. And that's pretty much it. And again, I've just put a comment in there just to say what it is as well. Not that that's necessary. Okay, so save that, exit out of that. The extra steps I mentioned before, setting engine models to regression. We go to engine, model, library, and then batch. And here we have regression ticked on. At the moment, I've also got halt ticked on as well as the Crostons one. So I definitely don't want it to use halt. So I'm going to untick halt and save that. Halt, by the way, is an engine model which doesn't use causal factors at all. And that's why it couldn't model. It's not able to model this causal factor that we've just created. So we don't want it to be messing up our results and getting mixed in with the regression results when the Bayesian blending kicks in. So we'll just that's why we're going to turn it off. So we'll close that. We're also going to ensure, like I said before, that our stat forecast and simulation series shows backcast, not just forecast. I won't bother showing you that, but it's the same as that screenshot I showed you before. You just go into the actual series and then just make sure it's got no client expression, and I can assure you that it does not. To set the forecast generation horizon parameter that I mentioned before, we go to parameters, system parameters, engine profile to batch, and then to the time tab here, and that's where you find this forecast generation horizon 500. All this is doing is ensuring that the backcast gets written to the database when the engine is run, and that means we can then see the backcast modeling and not just the forecast going forward, but the backcast as well. Okay, let's close that. That is set to 500 usually out of the box, so normally you don't need to change that one actually. All right, so let's go into Demantra itself. Let's imagine we've been in Business Modeler, we've restarted the web server so that our new series will get picked up. We'll now go into Demantra. This, by the way, is the, Deb, maybe just tell me when you can see the Demantra My Worksheets screen come up.
Yeah, I think we're with you. I can see you're moving your,
all right.
I see the My Worksheets. Yeah, yep, we're good.
Excellent. Okay, So this is the UI for 12.2.6, by the way. So you may not be quite used to or familiar with this particular UI, but this is how we get into the worksheets these days with 12.2.6. So what I'm going to do is go to the worksheet that I've created before. Open that one up. And you'll see pretty much the same view that I showed you earlier with the history that I put in and the whole forecast that's being generated. Okay, so what I want to do first up is add my series, my demo causal series, into the worksheet. So we're going to go to here and go and find demo. Okay. Demo local causal, add that one in. Okay, rerun the worksheet. Okay, excellent. We'll just save that as well. So what I'm going to do is I'm just going to simply mark the historical periods where my history override is 200 compared to 100. So I'm just going to stick a 1 in there. It really could be any number. Just make it consistent between all the different entries that you do, that's all. So I'll put a 1, we'll go down and find the next 200, which is right there, put a 1 there, another 1 there, 1, and then 1, 1, 1. So just a marker. Save that data. And what we can also, well, we can actually run this simulation right now without worrying about the forecast. This will just model the backcast. So why don't we just do that for starters, actually. So I'll run the simulation. And look at what it's done. It's actually completely 100% modeled the whole backcast so well compared to the history that it's actually completely overlapped it. So you can see that the simulation here is absolutely identical to the history. Now, of course, that's not realistic. No one's ever going to have such data which is so perfect as this. No. And we can talk about that in just one moment, about what more realistic data will model like. But at least shows that the modeling is working. All right, so now if we want to then go and put some events in the future, because remember what we're doing is we're saying we believe there was an event run at that point, there was an event there, an event there, an event there. Now let's say in the future horizon, let's say we have an event there, and then another one a few weeks later, and another one a few weeks later. So we've got, say, 4 events going forward in the future. Again, I save that, rerun the simulation. And voila, you have now a forecast going forward with a flat 100 units in every single week, except for the ones where we have events identified. And I think that shows just how effective using a local causal factor really can be. Now, what I thought I would also do is show you a couple of examples of data which is more realistic. So what I did here was I took some real historical data from a random client from a few years ago and generated a forecast. And then what we can do is go and model that kind of data with some events being modeled as well and see what it does to the forecast. But before I do this very highly seasonal combination, let me just do a more basic one first. So in this particular combination, we have a series of data which is, in one sense, reasonably stable, but it's also quite up and down from week to week. But overall, you can see that there's a fairly consistent trend throughout the data heading upwards. But there are quite a few places where it might be possible to say, you know what, maybe some of these spikes were actual promotions or some kind of events that were run, and let's go ahead and try to model that data with the same kind of concepts that we used before. So I've gone through and already marked where I think there's been historical spikes historically. You can see that's where those little purple dots are. So if I go and run that, and I've also got some future events modeled as well. So if I go run ahead now and run the regression, now that I've defined that causal factor, and compare the new forecast, the simulation, to that original forecast, then we should see some really stark differences. Because before, all we were modeling for was just trend and level, and that was all. So now we're modeling for trend and level and historical events. So I've gone to mark where I've put these markers in to say that each one of these was a historical event. Now we have a spike that's being generated historically, and also going forward we have spikes. And the other thing that's also happened commensurately is that the overall level of the forecast is being lowered a little bit from week to week, apart from where the spikes come, and also the overall trend has been lowered a little bit too. So that's kind of interesting. Now, let's go back. Well, actually, let me go to this one here as well. Here's another example where not only do I have spikes in the data, but I also have a few spikes, but actually the spikes are not particularly strong. But what we do see is places where there are potentially what we might consider to be out of stocks, you know, where the history has gone to zero, and possibly that is explained by the fact that we were out of stock. So I can use this same causal factor in exactly the same way, not only just to mark an uplift in data, but also a drop in the history as well. So what I've gone through and done already is just gone through and marked those historical points where the history is really low. So let's see what happens when we do that. Let's run the simulation. Oh, okay, I don't know what I didn't like there. Let's try again. So now those historical data points where the history was low have basically been quarantined, if you like, from the rest of the history. So we've basically marked it and set it aside and said, you know what, they're not good data points. We don't expect any out of stocks coming forward in the future. So I just really want to quarantine that data and set it aside. So it's not like I'm going to go and say, oh, I'm expecting to get an out of stock in May in this future horizon. That would be probably a bit silly to do, but I can at least quarantine that historical data. As it turns out, it didn't make a huge difference to the forecast. Now, I want to go back and have a look at this one, which is a bit more complicated because it's also got historical seasonality, which is really evident in the data as well. However, you might remember before that I had all my seasonal causals turned off. So I need to go back to the causal screen just quickly. And for the short models, again, we're using regression, which is a short model. What I'm going to do is go and turn on all the historical seasonality causals as well, D1 to D12. Save that. Now go back through to here, because otherwise, if I don't do that, what's going to happen is the forecast is just going to be a straight line modeling trend only up through the data, and also my new demo local causal. So let's run the simulation again. And you'll see that again that I've modeled some of these spikes here as being events. So rather than seeing this purely seasonal forecast going forward, now I'm seeing a seasonal forecast overlaid with future events which I've identified. All right. So that takes me to the end of the demo. I'm going to go back to my slides now and just mention a couple of things. So there's the result on that screenshot. I wanted to show you a couple of other things as well. If you forget to set the causal in a particular week, all that happens is that the sales fluctuation, this spike in this case, will be interpreted by other causal factors. And in this case, it's going to be interpreted by the trend, that's the T causal factor, and therefore the whole forecast will basically downward slope a little bit because it's not marked, it's not seeing that one any longer as a spike that's anything to do with an event. It's just seeing it as part of an early increase in sales, which then causes the overall forecast to trend downwards because it's seeing an increase earlier and a decrease later, if you like, and so an overall trend goes down. A warning about using more causal factors than is warranted by the data. There's a real problem in forecasting called overfitting, which basically means you're using too many causal factors. And it means that the basic effective is that while the backcast might look really beautiful and aligned to the actual history, just like we saw before, the forecast itself may have no predictive power. You must have at least one data point per causal factor. That's one historical data point, per causal factor. But usually that's quite inadequate. Usually you would typically want, say, 2 historical data points per causal factor. I mean, let me give you an example. If you had 12 months of history and you had 12 seasonal causals, D1 to D12, all turned on, the forecast that you would generate would pretty much just be a copy of the historical 12 months of history that you had. And it would look quite nice. It would just be a copy of the historical data. But it would probably be a completely inappropriate forecast because it's only got one data point per causal factor, which is driving the future forecast, which means that it's very uncertain as to just how strong that seasonality really is, since it's only got one data point to go on per causal factor, that is. So statistic textbooks may actually tell you that you should have even more than 2 historical data points per causal, maybe around 5 or even more than that. But if you're really sure of the existence of the causality, then you can use less than that. Maybe just 2 would be adequate in that case. If you have a really highly predictable seasonal market, you're really sure of it. But that's just a warning. A config tip for you as well: ensure that your T, that is the trend causal, is turned on when you're using a local causal factor. I actually found that if T is turned on, the local causal factors don't work. That might be a bug. I'm not 100% sure, but I would consider it just to be a bug. But anyway, it's usually required to have the trend causal turned on, so it's not a major problem. Okay, so now I'd love to open it up to Q&A.
Thanks, Andrew. I'd like to introduce also at this time joining us is Daniel Rainers, who is a principal consultant with AVATA, an expert on Demantra and Cloud DM. He's going to help us with the Q&A. And Daniel, I believe you do have a question for Andrew.
Yeah, hi everyone. Andrew, I have a few questions here coming in, right? So one is basically, is this causal functionality available in all Demantra releases or only in the newer releases? Do we have an answer for that?
Yep, no, it's been there right from ever since I've been using Demantra, and that's all the way since Oracle bought the product, back in 2006. And it's probably, well before that as well. So yeah, all releases. And, and as I said before, the local causals are available in the DM, the basic product. So you need AFDM for promotion causals and activity shape causals, but you don't need it. You don't need AFDM for locals and global causals.
Yeah, and there's another question that might be related, right? How many causals can be set up, and is there some kind of technical limitation? I mean, you mentioned already overfitting, that it might be not useful to set up more than, let's say, 1 or 2 causals, right?
Yeah. Well, I mean, a lot of the time you have those D1 to D12 turned on for the purpose of doing the seasonal modeling. So there is a restriction in the DM license. You're only supposed to be using 20 causal factors at most under the DM license, whereas under AFDM you can actually have unrestricted numbers of causal factors. So if you've only got 20 to use and 12 of them are already taken up by D1 to D12 seasonal factors, and there's also a constant causal as well, and T for trend, then that pretty much leaves 6, right? So that's 14 of them that you've already taken up. That pretty much leaves about 6 causal factors for you to use your own custom causals or whatever else. It doesn't necessarily cause a major drama because sometimes you don't need all of D1 to D12 turned on anyway, unless you have a very highly seasonal market. So it's usually not a big deal that you've got 20 causal factors to choose from. And as you say rightly, Dan, overfitting can be a problem. So you keep on adding more and more causals, you can be causing yourself a problem actually, where you think you're creating a really good forecast, but in fact you're not. And the reason why that usually happens is because often historical sales is random, right? It's not perfectly flat like what I was showing before. So if I just quickly flick back to what I was showing before, you can see there's, even in this highly seasonal product, there's still a lot of random variation. So what if I was to try to model every single week in this weekly model as a separate causal factor? I would need 52 causal factors, but would my forecast be any better by modeling 52 causal factors, trying to model every single week separately from each other as a season, to try to model seasonality? No, I don't think it would probably be a good idea.
Yeah, right. Can you actually see if the engine has taken a certain causal factor into account? Is there a way to see it somewhere in Demantra?
Yeah. But you have to go into the back end, unfortunately. There's a table called interm _ results. Interm being short for intermediate, INTERM _ results. And it's a table that sits in the Demantra schema in the back end, and that shows you which causal factors have been used. So it's not really readily accessible by a user, more by like a DBA.
Okay, so you cannot see it from the worksheet itself, so you have to look into the engine log files, basically, right?
Yeah, it's kind of like a log. It's not really a log file per se. It's an actual table that stores all those results. And even then, you have to configure a particular setting to make that even turn on. Right, okay. Intermediate results is the name of the engine parameter that needs to be turned on to make that happen.
Okay. You did the tests with the simulation engine, but I believe the batch engine will take the same settings into account as well, right? So
yes, it will. Both, right? It will. There are, in some releases, some few little bugs with the simulation engine, so it sometimes does not do things exactly the same as the batch engine. I can't really go into it right now, but I have seen a couple of quirky things over the years, which Oracle may or may not have solved in various versions. But generally speaking, you'll find they'll be exactly the same. The one other caveat is that sometimes people will put different engine parameters into the simulation engine profile, so you can get caught out where you think you're running the engine with exactly the same parameters, but in fact you're not, because the simulation profile has got some extra things turned on. For example, you might have outlier detection turned on in the batch engine, but then you have it turned off in the simulation engine, and of course that's going to cause problems in terms of you're going to see differences between the two. So you do have to be careful about those things.
Right, and potentially also the forecast level, right? The batch engine is using the entire forecast tree, right?
Yep.
And they're looking for a correlation. I mean, how does that work actually, right? If you're running the simulation engine on a certain level, it only looks to that particular level, and if there's a correlation with the causal factor, or is it also looking through the entire forecast tree?
If it needs to go up the forecast tree, I think it will do that successfully.
Okay.
Yeah, I think so.
All right. So in this case, it's similar to the batch, and even if you run the simulation, and then it still starts from the lower level and goes up to a higher level. Okay.
I think so. You put me on the spot. I'm not 100% sure about that.
sorry for that. Okay, I think there's one question coming in actually right now. How does entering different integers in the causal series work, like 2 or 3 rather than 1? And if, for example, you want to model harder hitting events, so how is that possible to model that?
Yep, great question. So what you can do is, if you decide that one particular event is a low impact event, then you could call that a 1, and then call a medium impact event a 2, and a high impact event 3. And that way the engine will actually see a correlation between the impact of the event and the causal factor you're creating. So in fact, you could definitely do that and improve your results even more, given the fact that your events historically won't all do what I did, which was do something very simple, right? Which was just to say they're all 100 units. But if one of them was, say, a 30 unit increase, another one was a 50 unit increase, another one was 80, another one was 100, then you could maybe model the smaller impacting events as a 1, like I said, and the medium ones as a 2, the next ones as a 3. And it doesn't even have to be 1, 2, and 3, right? It can, because it's a number, it doesn't have to be an integer. It could be a 0.5 or a 1.5 or a 8 or a 8.3, you know, whatever you like, whatever makes sense.
Okay, thanks. All right, there's no additional question right now, so I think we can wrap up.
So what we'd invite you to do is to contact us for a free second opinion, an analysis of your Demantra configuration. If you've got any questions about how things are working, I mean, often people run the engine and they see some things that they would consider to be, you know, just inexplicable results, and they just don't really understand what's going on. I mean, the engine, as I mentioned before, is so highly configurable with the forecast tree and all the 300 engine parameters and all these different causal factors and so forth, that when we do engine tuning, you know, there literally is thousands, if not millions, of possible combinations of how you can configure the engine. So if you are seeing strange things come up and you don't understand how the engine is producing those results, then I would really encourage you to contact us and we'll take a look and we'll give you a free second opinion about what's going on and we'll provide some recommendations about how you might, what might need to change in your configuration, or whether perhaps you need a full-on engine tuning exercise to solve those problems, or whether they're in fact just easy things that can be solved. So I invite you to do that.
All right. Thank you both for all of that great information. And as always, we invite anyone to contact us via email, visit our website, and follow us on social media. Thank you all for joining us, and enjoy the rest of your day.